Hi there and welcome to this video. Thanks for clicking on and watching. Hopefully you've done so because you're sitting Maths Edexcel A-level this summer and paper 2 is on the 14th of June. This is the list from the exam board of the advanced information topics for paper 2, and I have done a series of videos looking at one or two questions from the advanced information topic tests based on this list. So do be sure to check them out and definitely have a look at those topic tests. In this video, I'm just going to have a look at some other questions that I've found based on geometric sequence and series, because with trig identities there weren't many examples of those, and I've also included a question on binomial expansion. So on the advanced information on one line, it says geometric sequence and series trig identities. So here's a question that I found from an old IB paper where we do have exactly that. We've got a geometric sequence with some trig, and we're going to involve some trig identities. So if we've got sine x and then the second term is sine 2x, using our trig identity, this is a double angle formulae, and sine 2x is 2 sine x cos x. Now what happens in a geometric sequence? It's the common ratio that you times by to get between the terms. And now that I've written that second term in terms of 2 sine x cos x, I can see that r is equal to 2 cos x. What do you times sine x by to get 2 sine x cos x? 2 cos x. Now I need to times by the same r to get to the next term, and if you times this second term by 2 cos x, you do get the 4 sine x cos squared x. So the common ratio for part A is that r is equal to 2 cos x. Now in part B, find the set of values of x for which this geometric series converges. So the difference between a sequence and a series is when you have a series you are adding all the terms up, and a series converges where the mod of r is less than 1. And another way to write that is to just think that r has to lie between -1 and 1. So what was our r? Our r is 2 cos x. So r minus 1, which is 2 cos x, has to lie between -1 and 1. Now we just need to solve that inequality. Dividing both sides by 2, we'll get that cos x has to lie between minus a half and a half, and we can see that the domain for this sequence is that x is going to lie between minus pi by 2 and pi by 2, so that's minus 90 to 90. So let's have a little look at the cos graph. Cos comes down like this, and it is symmetrical about the y-axis. So this is our minus pi by 2 and pi by 2, so we're just in the top bit of this graph above the x-axis, and we're thinking about where does cos x lie between minus a half and a half. If we go across at a half, the actual angles there, that when you have cos 60 you get a half, so in terms of radians that is pi by 3 and minus pi by 3. So we don't want the cos to be above a half, we want it to be below. So it's going to be this part here and this part here. So as long as x lies between minus pi by 2 and minus pi by 3, then we will be in this part here, or so union with pi by 3 less than x is less than pi by 2, which is that bit there. So as long as x is in either of those regions, then we will have a convergent series. Now in part C, it's asking us to consider x so that arc cos of a quarter is equal to x. So arc cos means inverse cos, so cos to the -1 of a quarter is equal to x. Now there's different ways you can do this, but I know when I'm doing inverse cos, I'm getting the angle, so the 1/4 must be the sides. If you just think about a right angle triangle, then the sides must be 1 and 4 adjacent over hypotenuse to get me the inverse of a quarter to give me that angle. So by Pythagoras, if I just square 4 and get 16 and take 1 away, this over here is root 15. Now I've needed to find that because in order to show that the sum to infinity is this root 15 over 2, sum to infinity you get on the formula book is a over 1 minus r, and a is our first term. So our first term is sine x, and sine x, if this is our x that we're being told to consider here, then the sine is opposite over hypotenuse. So that's just going to be root 15 over 4 is a, divided by 1 minus r, and r is 2 cos x, and cos of the angle we're told here is a quarter. So we need to times that by 2. So it's 1 minus 2 quarters. So this is going to be root 15 over 4 divided by 1 minus 2 quarters is a half. So divided by a half. When you're dividing by a fraction, you need to turn that upside down. So this is going to be cancelling 2's into itself once, 2's into 4, 2. So it's going to be root 15 over 2. Okay, this is another geometric series and trig identities question. So found another one. So this is telling us that the series goes sine theta, cos theta, and then a half. We get between the terms by the same common ratio because we are told it is a geometric series. So how do we get from sine theta to cos theta? We are going to need to divide by sine theta and times by cos theta. So if we do the same from cos theta to a half, we'll get that cos theta times the common ratio cos theta over sine theta is equal to a half. Timesing those numerators together, we'll get cos squared theta over sine theta is equal to a half. We can see where we're going is a quadratic in terms of sine, so we need to get rid of the cos squared, and we can replace that with 1 minus sine squared all over our sine theta is equal to a half. Then we can just cross multiply, take that 2 up, we'll have 2 minus 2 sine squared theta is equal to sine theta, and then just rearrange and take the quadratic term over to the right. We'll get 0 is equal to 2 sine squared theta. The sine theta has stayed still, and the 2 has also come over to be minus 2. So we've got that for our 3 marks for part A. Now part B, it tells us that given that theta lies between 90 and 180, find the values of theta to 1 decimal place. So we can see we've got to solve this quadratic to find the values of theta, and to 1 decimal place we're going to be using the quadratic formula. This doesn't factorize, so we can't find any values that's going to work for. So using the quadratic formula, we've got minus b plus or minus b squared minus 4ac all over 2a, given that a is 2, b is 1, and c is minus 2. So this will give us answers for sine theta, which will be minus b minus 1 plus or minus b squared 1 minus 4 times 2 times minus 2 all over 2a, which is 4, which is equal to, with the minus here and the minus, we're going to have 1 plus 16, so minus 1 plus or minus the square root of 17 all over 4. Now when you do this, if you do the top one, the minus 1 plus root 17 over 4, that gives you a decimal. We can inverse sign on that to get what theta is. When you do the minus 1 minus, it takes you below minus 1, so that's a non-solution. So it's just the top one only gives you one answer. And when you do minus 1 plus root 17 all over 4 and inverse sign of that, it gives you the angle is 51.33. That's what your calculator gives you. But look at the interval that it's wanting. It's wanting an answer for theta between 90 and 180. So using your sine graph, Your calculator has given you this angle here, 51.33, and we just use the symmetry and we can do 180 minus it to get that theta is equal to 128.7 degrees, and then it will be in the right range for required by the question. Right, part C, hence prove that this series is convergent. It is convergent if our R is between -1 and 1. So what is our R? Our R is cos theta over sine theta. So if you just do cos of 128.7 divided by sine of 128.7, that comes out to be -0.8. So series is convergent. For series to be convergent. Okay, so we've done that part C. Part D, I should do that here. Find the sum to infinity. The sum to infinity is A over 1 minus R. Now A is our sine theta, so that's going to be sine of 128.7 divided by 1 minus 0.8. I think it was 0.80115, so you can put further degrees of accuracy in there. But if you do all that, then that will come out to give you two significant figures, 0.43. Quick question on the binomial. You've got a plus 2x all to the 7. You get on the formula sheet that a plus b to the n is equal to a to the n plus nc1 a to the n minus 1 b plus nc2 a to the n minus 2 b squared plus, I think you get the nth term in there as well, but then the last term will be b to the n. That's how the binomial expansion works. But here we've got that a plus 2x all to the 7, and we're told that the x to the 4 term is 14120 x to the 4. The coefficient is just the number in front. So looking at the way the expansion works, you can see that the term on the second term in the bracket b squared is the same as the 2 on the NCR button. So we're going to have the 15120 x to the 4. To get the x to the 4 term, it will have to be this second term, 2x all to the 4, and then that will be times by the 7c4 on the front, because the number on this the NCR button is the same as the power on the second term in the bracket, and then the first term will just be a cubed, because these two powers here, the 3 and the 4, have to add up to the n. So we don't need to write it all out, we can go directly to that term. Now on your calculators, 7c4 comes out to be 35 a cubed, and then you just have to remember that this 4 has to operate on everything in the bracket that's on that second term, so that's going to be times 16x to the 4 is equal to our 15120 x to the 4, so that everything with the x to the 4, the 35 times the 16, which comes to 560 a cubed, must equal the 15120. So a cubed is 15120 divided by 560, which comes out to be 27. So a must be the cube root of 27, which is 3. Thanks for watching the video. Thanks for staying till the end if you're still with me at this point. Do like and subscribe if you found the content of the video useful and helpful, which I hope you have. Good luck for Tuesday with your paper 2, and I will see you on the next one.